Hello, kids. Today we're going to talk about cube, and we're going to find the volume of a cube. What you need to know that volume is amount of space an object takes up. So, and it's in cubic units. So let's start. We're going to learn how to use this grid shape to create a cube. So I would like my cube to start right here in this corner, and it's going to be 1, 2, 3. Let's do 4 units. So this way, and that would be the width, and then 4, 1, 2, 3, 4 going to be my length. And then I need a height of a cube. So I'm going to use 1, 2, 3, 4 because cube has to have all four sides the same. So I'm going to use all sides are the same and all are squares. So we're going to, we can use our two triangular rulers to help us find where this length needs to be parallel to the top of the edge of a cube. So we can make this line to be or parallel line to the bottom. And then also the height is also shown in a cube to the end this way. So this will be our parallel height to, so this line is height, this line, and this line. And as well, the lines behind that we want see if we are creating our cube. So let's see if we do this, and also if I take that line, can be parallel the length, and then again this will be my length that will be parallel, and then the last the edge that we can see that is parallel to our width. So here it is 3D shape called cube. So we can see because we use in a cube all the sides are the same length. So we call them, for example, S. So S is equals 1, 2, 3, 4 units. This and then we know then this is S also, this is S. If all these are S. The length, the width, and the height. Every volume formula is length times width times height. So the volume formula is a long side times short side and times height of that 3D shape. Since we have all sides to be S, our volume, I'm going to move this a little bit up so we can see. So let's start over. So the volume usually is length times width times height. That's a formula for any prism that we are working on to find a volume. So volume of a cube is a little bit different because length is the same as the width, and the width is the same as the height. So we practically have to multiply the same length 3 times. So we can use that as a volume is equals S on a power of 3 or cubic S. Cubic S. How we can show that? We can show in the presentation about if I take one cube, and that is the length, and then this is a width, and then in height we can see that how many of these size of the cubes are gonna cover the whole shape, whole cube. So that would be the, so if I take another color, I can show that the bottom would be this. So I won't be able to see this, the top of these cubes when I create a new one. So I can, let's see, if I change the color, it would be like this. So this would be on the side, the color, that would be a different cube. Okay. So I'm going to just draw and cover with that to change the color in kind of reddish. So here's another cube that will go here. And then if I take the, let's see, this one, this part I won't see because I will put another cube there. So it will be the blue that we can see. Okay. And the last one will be seen all because we can see the sides of this cube and the top of the cube. If we're going to build that cube filled with the cubes of this size, it could look just like that. And then we can alternate the colors if we wish to make a different. So just make, if this is a green one, and then can do this to be a yellow cube. Okay, and then the last one could be blue all the way through. Kids like to do this, and it helps your brain to relax when you are drawing, but it makes visual spatial intelligences, so you can see that you don't see the sides, this length in the back. You can imagine that side, but you don't really see it when you create the cube. Okay, and then let's do the blue here. Okay. It's pink. Yellow. We just made a one row of cubes almost. So if we do this one to be reddish, we can do yellow and then color with pink, so it will give us red color. Good. Okay, this could be the yellow. Green. This is a one row of one column of the cubes that will be part of that big cube that we are looking for. How big is the volume? Okay, we can do let's just make a little bit alternation so I can go quicker. Okay, this one should be green all the way. And I can see the top as well. So to be visual spatial, we have to be able to, in your brain, to see the cubes, imagine them, turn them around, and make them visible in your brain. So you will be able to understand how the shape can shift in space, move to the left, to the right, how it can flip, how it can slide or transfer in the space. Okay, let's do the yellow here. Okay, yellow here, yellow here. Let's do yellow here. And yellow here. Okay, a few yellow. And then let's see pink some. Them. Okay. Green here. Blue. This could be a hole. Let's see the top of the cube. Blue. Okay, and if I take this to be red, this. Blue here. And the yellow. And here we go. We have a representation of how it would look like if we will create a cube of different cubes this size. So let's see how much we will have. We can think about this row being the bottom. So we can say the base could be 4 times 4, which is equal. So the base or bottom base 1 could be 16 square units, and then base 2 would be 16 units as well, and base 3 or height 3 would be the 16 square units, and then base 4 would be 16 units. So we can calculate and check our answer by adding these, the bottom areas that covered with the cubes, or we can multiply the 4 units times 4 units times 4 units, which will give us 4 times 4 is 16, and then times 4 4 times 6 is 24. Remember 2. 1 times 4 is 4, plus 2 is 6. So it's 64 cubic units. So cubic units. Okay. So that is our volume of this cube. In the 6th grade, they usually say, what if our cubic units or cubes are maybe we want to have a smaller, even smaller units in them, so we can really measure this one. So when we see that the cube, actually the cube is 2 centimeters, so I can demonstrate this by having these 2 centimeters right there, and then other 2 centimeters right there, and then 2 centimeters right there. And if I cut this one also, it would be about right here. So if I want to put even smaller units of this would be 1/2 of a 1 centimeter units, because the cube are 2 centimeters. Now I want a 1 centimeter unit. How many I can make in there? So we can demonstrate that if I needed to put smaller units, cubic units, than this one in each of my bigger cubes, I actually gonna create 8 cubes, and I can show you how that looks like. So I can see that here I will have a 4, and then also there can connect these dots, and you will see. Then I will have 1, 2, 3, 4, 5, 6, 7. There is on the bottom 4. So 1 and 1, 2, 1, 2, 3, and 4. Then you don't see. And then on the top are 4. 1, 2, 3, 4. So that's 8 smaller cubes are in this one bigger cube that is that we know that this whole cube is 64 cubic units. And then when we measure each of that, it's 2 by 2 by 2 centimeters. So if I want a 1 centimeter cubic cubes in all this shape, I need to have this volume multiplied by 8, because I have 64 these size of cubes. But now times 8, because each will fit 8 centimeters once, then I will cubic centimeters. I will have, what would be that cube look like if I have this size units in them. So I need a multiply by 8. And then 4 times 8 is 32. 2, I remember 3. 6 times 8, 48. I can put on the side and add if I need to do that. So that would be 51. 512 cubic units would be this cube. 512 cubic centimeters. So cubic centimeters. Cubic centimeters. Or the little power of 3 with cm later. And this is how to find, I'm sorry, I needed to show you this, what I did calculate So that is the lesson on the volume of a cube by using a grid. I hope you enjoy and I hope you learned something from me. Thank you very much.